This is a Nimble Storage SAN. What's a SAN, you ask? SAN stands for Storage Area Network, and you usually see them when storage and replication is very, very important. You got to store your data. It's critically important, that's why you're spending so much money. Storage area networks and this Nimble will let me show you that SANs are not nearly the modern marvel as your SAN salesperson would have you believe. By the end of this video, I'm gonna hopefully have you clued in enough as to what SANs are and how they're useful and how you buy one that you'll definitely make your sales guy super nervous. It's not magic, it's just a computer. Alright, what a SAN is supposed to do for you is to provide a highly available and reliable storage pool to a group of servers. Now, like I said, SAN is an acronym that stands for Storage Area Network. That doesn't look like a network, it looks like a server, possibly two servers. But somebody has put a lot of thought and architecture into all the common ways that failures can occur for the storage component of your servers. And so typically it has its own connection, its own network, not necessarily even Ethernet, it could be more exotic things, it could even be PCI Express, but it's designed and architected with the common types of failures in mind so that it stays up even through failures. The compute doesn't matter, it's the storage that matters. So I could have a whole bunch of servers that are running compute and running virtual machines, but where are those virtual machines stored? They're stored on the SAN. And if any one of those compute nodes goes down, I can just reboot the virtual machine on another computer and I'm good to go. If your computer crashes, you can take your hard drive out and get your data back, assuming that your hard drive didn't crash. Well, SANs are engineered to withstand the hard drive crashing part of that to make it so that you can just run your virtual machines anywhere. You can get to your storage from anywhere on the storage area network. That's different than network attached storage. Network attached storage implies that it's just network attached storage. SAN implies that there's some smarts, some brains behind it, some replication, some failover, some, oops, Jerry's not here today, I guess I'll just fill in for him. And that's a lot of the magic that you see in these sales presentations. A good SAN, like I say, can cost hundreds of thousands of dollars. Typically you would have more than one, storage node in your SAN, some local, some remote, because disaster recovery. It would tie in with your backup system, and the cost and the complexity of that, the salespeople make it seem like it's some grand thing, like it's the Wizard of Oz and couldn't possibly comprehend. But at the end of the day, it's the same sort of building blocks. It's just a server, or two, or three, or seven. And actually, you wouldn't want Wizard of Oz level grandioseness. You want something rock dumb simple. And there's also, there is a software component where you can have innovation, and there's a hardware component where you can have innovation. And sometimes the special sauce is in hardware, sometimes the special sauce is in software. It depends on the vendor, because every different vendor is trying to do something special because it is so commodity. As for Nimble, they're not around anymore. Nimble was bought by HP for $1 billion. So Nimble's kind of HP at this point, and I think Nimble's, the brand is still around, but it's HP. And this one is more than 5 years old, so it's end of life. And the components that it's made of are actually even 10 years old. So it's pretty obsolete. Like I say, you want something rock dumb, simple, and proven, so it's not really the same timeline. First up, a SAN, it's just a computer. Let's look at the back of it. We spin it around, we take a look at it. It doesn't exactly look like a computer. There's no USB or VGA ports or anything like that, but wait. Is that looking more familiar? A SAN is just a series of computers. You look back here and, we didn't see it, but there it is, this connector. This is a standard Supermicro connector. This is a Xeon processor, socket 1366, 2 sockets actually, currently outfitted with 12 gigs of DDR3. Normal PCIe slots here on this side. This is a standard, completely standard Intel 10 gigabit Ethernet. And there is this sort of long PCIe card that is a little bit of hardware special sauce. But wait, what's this? If you look here on the front, it says Supermicro. And if you look here, it says Supermicro SAS controller. Yeah, the controller, the motherboard, this is Supermicro designed. This is just standard PC hardware. In the breakdown of the anatomy of the SAN, we have this weird card that I'll come back to, and our 10 gigabit Ethernet card, serial attached SCSI interface, and then there's all these connections at the front that go with the chassis, and the drives. And we'll get to the drives in a second, don't worry. This is a completely standard Xeon processor and a completely standard Supermicro motherboard. Now, Nimble is actually running a custom BIOS on this. To be sure, this is socket 1366. It's long since obsolete, but this particular SAN hardware is a great training platform because the Nimble OS is very good for what it is and has a lot of cool software features, but we'll talk more about software in a minute. I've got our PCIe 10 gig interface here, and there's two 10 gig connections. And then we also have the onboard management connection on the bottom. Yeah, it's Supermicro's IPMI. Again, customized a little bit, but you can undo that. And then another 1 gig interface on the motherboard. And there's even a free PCI Express by 8 slot. The top slot is occupied by a Netlist battery-backed 1 gigabyte RAM card. So this is where the transaction log would go for file system operations. So one of the common ways that a SAN can fail or enter a failed state is if both nodes lose power. And we'll go over how both nodes work together in tandem in a second. If both nodes lose power at the same time, which is not an uncommon way for something to fail. I mean, a UPS can go bad, or a power rail can go bad, or the power can just go out at the data center for an extended period of time, and maybe somebody forgot to set the battery back up to shut things down. What was happening with the system at the time can live on in this card. This is basically standby power that is meant only to keep the memory powered. We can also count on this thing never going bad because it's basically a supercapacitor. In the past, there would actually be a battery in here, but on a long enough time scale, the battery will go bad, so we don't really use batteries anymore. We use supercapacitors because they will last forever and ever and ever and ever. So this thing, basically, when it boots up, when it does get power, it's able to look at this and say, here's the last several things that were supposed to be written to disk. Have they in fact been written to disk? And if the answer is yes, then it's able to discard what's in RAM. Or it's able to do an integrity check where it says, well, the disks say that they wrote this stuff out, but did they actually? And that's handled in software. And there's a little bit of that software magic that we're talking about. There's multiple processors in case your SAN is doing something where it needs a lot of processor, computing CRCs, or handling, backup jobs, or things that eat up a lot of CPU. In this configuration for this SAN, this is only a total of like 28 terabytes with a couple of SSDs for cache. Doesn't really generate a lot of CPU overhead. And then we've also got our serial attached SCSI interface here, which provides the physical interface for the disks. Now, I know what you're thinking. Well, if one of these compute nodes goes down, won't it take a bunch of disks with it? Like if this, SAS controller fails, isn't that a single point of failure because there's only a single SAS controller on this node? And the answer is yes. If this controller fails, but everything else is working on the node, it's going to take the node out. But that's the difference between serial attached SCSI, SAS, and SATA. Now remember I said there's two nodes in this one chassis. There's two physical separate servers. Supermicro did provide an internal link between those two servers so they can exchange information. But what happens if one of the nodes goes down and it was reading and writing from, some of these disks in the front? 1 terabyte SATA WDRE4, 64 megabytes of cache. So we look at this drive and it's like, this is just an ordinary, enterprise label from Western Digital to be sure. This is just an ordinary SATA hard drive. But then you look at the back and you've got this little circuit board. And this little circuit board has a couple extra gold contacts on the top. This is what's called a serial ATA to SAS interposer. Now, some modern SANs that are designed for use with SATA hard drives will actually include this electronics on the back plane, so you don't really have an interposer like this anymore. But for SATA, you got to have that there somewhere. This is really critically important. You can use a SAN without this, but if the SAN is designed to use this, you do yourself a disservice by not using it, because this provides a dual path to this physical hard drive through more than one controller. This little board basically acts like a traffic cop. So there's a primary and a secondary interface. Both of those interfaces each go to a controller in a different node. So this hard drive is actually hooked up to two different computers at once, physically, electrically. SAS hard drives, on the other hand, like this one, this is a Seagate Constellation ES.3, and this is also a 1 terabyte drive, and Nimble has helpfully labeled it with a sticker, SAS. And notice there's no interposer on this, but if you look closely, it's not actually even a SATA connection. It's a solid bridge across the back instead of having a gap. And if you look really closely, you can see that there's actually that extra set of gold contacts. So this drive is designed to be plugged into two different interfaces simultaneously. The idea with that is that if one of those nodes in the back of this goes down, the information on this drive is still accessible. Now, one thing that this is designed for that's not unique to SANs is drive failure. And that happens in servers. And you're probably already familiar with that. RAID, redundant array of independent disks, or redundant array of inexpensive disks. That basically slices up your data with extra copies so that if one of these mechanical hard drives fail, the data can be reconstructed with the data that's available across the other drives that are available. And depending on what your strategies are in terms of performance or redundancy, you can maximize the amount of space that you lose to redundancy if you don't have a lot of redundant copies of the data, or you can maximize performance by having a lot of copies of the data, because if you have a lot of copies of the data, then you can retrieve that data from more than one device if a particular device happens to be busy. If I split this chassis in half with mirrors, so like all of the data is on this side and all of the data is on the other side, if this were just a normal server and not something that's meant to be a component of a SAN, then if this side were busy with some other request and I came along and said, hey, I need my stuff, this side has an exact copy of what's on that side. And while this side is busy, I can get my stuff from over here. It's effectively doubling the performance. If you have just 4 drives, you might have seen this as like a RAID 10. A RAID 10 often is implemented as a stripe of mirrors, meaning that you have 2 drives that are mirrored, and then those are striped together. And so we can read the information potentially from 2 different drives at the same time because the information's on both drives. Well, the SAN takes that up a notch and can actually distribute the information to more than one chassis. So this enclosure on the bottom is actually not 2 more nodes and 2 more servers. This is just a bunch of drives. Similar to the setup above, just filled with a bunch of SAS hard drives. Lowly, pathetic 1 terabyte SAS hard drives. But this chassis has 2 SAS connections, one from each node, just in case a node fails, all of the drives will be accessible to the other node. A lot of the time in a SAN, it's an active-passive type setup, where one node is doing all the work and the other node is just sort of sitting there and making sure that the data is valid, possibly running background tasks like drive fitness tests or any kind of like data analysis or just, sometimes you get analytics. Like these virtual machines are generating all of the I/O. Those are useful things to have in a SAN for sure, and that's stuff that you should ask your salesperson. It's like, hey, what sort of tools does it give me for backup? What sort of tools does it give me for performance monitoring? Is deduplication an option? So if you have the same thing stored in multiple places, you can actually do away with it so that the information is not duplicated, except beyond whatever duplication happens as a result of the redundancy. So let's say that I've got this optimized so that it will tolerate 2 drive failures. But if I only have 2 drives of redundancy, and I've got 10 or 15, say Windows 10 virtual machines for 10 or 15 users inside my company, and that's what this SAN is doing, then I could use a deduplication feature so that I'm really only storing one master Windows 10 virtual machine image and then a whole bunch of other changes. And in reality, it's possible in some scenarios for that deduplicated virtual machine image to actually be faster than 10 different replicas of that virtual machine taking up 10 times the amount of space on my SAN. The conditions for that to be able to happen depend on caches that exist within the SAN. So the SAN's not really stupid. It's got a lot of storage for caching and acceleration and potentially a lot of memory. This one's only got 12 gigs of memory, but a modern one might have 128 or 256 gigabytes of memory, or an insane amount of flash. And things that are hot end up getting cached to flash. So if you have 10 users, each hitting their own VM, there's a lot of competition to cache each user's individual copy of their virtual machine. Whereas if you have deduplication, there's only one copy of that virtual machine with every different user's little bit of changes that they have to their individual virtual machine. That cache hit rate is going to be 10 times more effective because the deduplicated copy of the virtual machine lives in probably the flash cache or possibly even the memory cache. That's a lot to wrap your head around. Most of the stuff that you see online is like, oh, don't turn on deduplication because it's a major performance hit. And it definitely can be a major performance hit because the SAN has to do a lot of work to figure out which blocks are duplicated. But in some scenarios, it can lead to huge performance benefits. And so that's why it's important that your SAN software give you tools in order to be able to do that analysis and failover and redundancy and stuff like that. Another thing that's really important for the software component of it is that it handles those sort of software failures correctly. The most likely point of failure in modern SANs is really on the software side, possibly even on the connectivity side. So this one's Ethernet, could be fiber channel. Modern ones are even PCI Express. You go over the PCI Express fabric. Sometimes you see NVMe over fabric because you want all of the IOPS. Here's something that'll blow your mind. This chassis, as it's configured with a Nimble OS and SSD caches, which we'll get more into, maxes out at about 120,000 IO operations per second. That's a best case scenario. The latency that's possible with this setup minimum is on the order of about 2 microseconds. That's insanely fast. Your access time on a mechanical hard drive is on the order of milliseconds. Microseconds are a lot smaller. It is possible for you to have a situation with a SAN where the throughput and latency, if the SAN caching is very effective, is actually much faster than a mechanical hard drive, especially if you have an all-flash SAN. And that's one of the ways that Nimble was really famous. They had a relatively low-cost all-flash SAN, and it worked really well. And it was because they were one of the first companies to take a chance on flash. These drives in the middle, it is a bunch of Intel SSD DC3500 series 300 gig flash drives. These are exceptionally nice flash drives. But wait, what's that? An interposer. Yeah, Intel data center drives, they're actually SATA. You will need an interposer like this one to convert from SATA to serial attached SCSI. It was one of the ways that Nimble had, sort of cost-saving measures in place. But these SSDs are very, very reliable, and they're very, very fast for SSDs. At least SSDs that are that old. The drive configuration on top has 4 of those 300 gig drives. The one on the bottom's only got a single 160, so this would probably be configured with a couple of different storage pools in terms of performance. Definitely the faster performing drives are all going to be on top. But that's another question you can ask your salesperson is, what does it have for flash provisioning? Do you need special storage? Does it cost a lot extra? If your vendor is charging you thousands of dollars for a flash cache, but you look at it and it's actually built out of lower cost components, that is one way that a lot of vendors make a lot of money. Is like, on the base configuration, there's basically zero margin. But then you start adding things together and you get nickel and dime to death. So if you're considering buying a SAN, definitely do your homework on the hardware side of it to make sure that you're not getting ripped off on the hardware side. Let's switch gears for a second and talk about the software side, because the software side of a SAN is actually much more important than the hardware side. Like I say, Supermicro as like the base underlying hardware, I think that's great. We don't want to, color outside the lines with this. But Nimble OS on here, because it's just a PC, we can get rid of Nimble OS. We can put anything we want on it. I mean, that's not going to be supported or sanctioned or anything like that, but it's a Supermicro motherboard. And Supermicro actually offers the BIOS for this motherboard on their website, because the Nimble BIOS is locked down and you can't really do much. But if you install the Supermicro BIOS on it, yeah, you can plug in VGA and USB. There's even an RS-232 port. True NAS on this platform. You can go from about 120,000 IOPS with the current software stack on here to best case scenario about 500,000. And this is on old hardware. So I don't really would recommend that, but it is a great trainer platform though. Modern hardware, like that 11th gen i5 behind me, will easily go multiple millions of IOPS with 25, 50, or 100 gigabit Ethernet, but it doesn't have the failover and redundancy. And truthfully, you give up a few things with the 1 gigabyte memory backed card and things like that if you do go the true NAS route. On the software side, if you're buying a new SAN, things you need to look for are like your RDMA setup, because with the RDMA setup on this, with RDMA capable Ethernet cards, even on this old platform, you can still do IO operations on the order of 2 microseconds. And that is faster than a mechanical hard drive that is locally attached. Now your bandwidth might not be as good. A locally attached NVMe is still going to be 4 to 8 gigabytes per second, and pushing that over Ethernet is going to be really challenging, especially on relatively low clock and slow old Xeons. But on a modern hardware platform, 25, 50, 100 gig Ethernet should be no sweat. Minimum, I think, 4x 25 gig Ethernet on any kind of modern SAN that you're doing. 25 gig is pretty much the baseline on the Ethernet side of things, although PCI Express fabrics, ironically, are actually cheaper to implement than Ethernet and insanely way faster. But it doesn't scale as well if you've got, a whole rack of servers connected to your SAN, so keep that in mind. That's something to talk to your sales rep about and make them nervous. It's like, what are the trade-offs of having, a couple of different storage pods where we've got really fast interfaces to serve our critical virtual machine servers, and then we've got secondary slower links that are running on 25 or 50 gig Ethernet for connecting to, the data center wide SAN, or something that we have for replication, or something that's, architected elsewhere in the data center. These are sort of fun questions that the salespeople generally don't answer. The whiz-bang sales presentation is not really very much use to them. If you architect your solution for your business correctly, understanding what your needs are in terms of IOPS and latency and backup and redundancy and failover, you could really get a lot out of it. Another way that you can rearrange the hardware here, this only applies really to this nimble storage thing, is this is a storage chassis on the bottom, and this is our actual SAN storage node on top. And if we look at it really carefully, we can see that all of our compute is on top and the bottom is just drives, like I said. There's not much to the drive storage enclosure. I mean, it takes the same type of sled, but you can see it's just a serial attached SCSI interface that goes from here all the way back. If you wanted to get a Supermicro motherboard for this to put in, you totally could, or you could move one of the compute nodes from here down to this other chassis and just have a dummy connection for the other side of your drives. Now that's not good because it does away with your redundancy unless you're building a cluster with two independent nodes, because each one of these has dual redundant power supplies, and then we've got, this dummy connection. You can do some fun things with that, but that's not an officially sanctioned or supported thing from Nimble. If you're using hardware this old in production, it's on borrowed time. It's going to die. You need to replace it. You could literally replace it with something that you build running one of the free versions of TrueNAS. That would be completely fine. But I'm sure that you could call up IX Systems and have them hook you up with something that actually costs money and is actually pretty good. Because again, like I say, when you look at the man behind the curtain, it's just Supermicro. And how crazy is it that HP bought a company that was basically selling Supermicro stuff with their own software special sauce, and maybe a little bit of hardware special sauce in terms of the PCIe card that is for 1 gigabyte of redundant storage. Ironically, also, this is open source under the hood. So like the kernel module for that 1 gigabyte card, the source code for that should be somewhere on the internet for enterprising individuals. But the hardware is so old and crappy, just don't care. I just thought this would be a fun video to talk about SANs and the components of a SAN. One storage node does not really a SAN make, in my opinion. I think you need at least two of these with full replication, because even though everything in here, we've got redundant power supplies, redundant connections to the drives, redundant blah, 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 the software could still be a single point of failure, and ideally you have a full replica somewhere else. You can mitigate that a little bit by having good backups. For a SAN that is truly like what you would find in the data center, you'll have multiple storage nodes like these connected together, working together in tandem, so that if something horrible happens, they're able to deal with it. Side note, modern SANs demand so much performance that software developers have been trying really hard to find software solutions to hardware problems, meaning that instead of having a device like this where each server has a connection to some kind of storage network, we end up having servers that have their own local storage, and then there's some kind of a software replication protocol that handles distributing things across all of the servers participating in the cluster. VMware famously has a pretty good solution for this in their vSAN product. So you can have a lot of local storage, NVMe, spinning Rust, whatever, in physical servers, and you have a cluster of 4 or 6 or 8 physical servers that all have physical local storage participating in vSAN. And best case scenario, you get local IOPS. Worst case scenario, it comes from that InfiniBand or fiber optic or 25, 50, 100 gig Ethernet interface, which is the same speed that you would have had if you had a traditional SAN. So worst case scenario is still the best case scenario for something like this. And with technologies like RDMA, the overhead of doing it on the network side really, it's not that much. It's not a lot to worry about. But the potential upside is that you have NVMe-like IOPS. So instead of millions of IOPS, if you have a large NVMe, you're reaching into tens of millions of IOPS. And we're just sort of cresting onto that in terms of high-performance data center stuff, where we need a PCI Express fabric, and we need 10 million IOPS available to our virtual machines that are running on a single server, which will drive things like virtualized SANs instead of having dedicated SAN appliances that manage all of your SAN storage. But we're not there yet, or at least if we are there, and that's something you're considering buying, that's moving way up from the $100,000-ish price tag. Not quite there yet, but getting there. And that's why VMware's vSAN product costs what it costs, is because replacing these things in software is not cheap. It requires a lot of validation. Humble, this is level 1. This has been a quick look at SANs, and definitely a lot of information to make your salesperson nervous if you ask the questions. I'm signing out, and you can find me in the level 1 forums.